This is the first video to Chapter 2, Section 1, and in this chapter we'll be discussing descriptive statistics. With descriptive statistics, we're studying numerical and graphical ways to describe and display the data. In Section 2.1 specifically, we're going to learn the stem and leaf graphs, the line graphs, and the bar graphs. And we'll see right here that a statistical graph is a tool that helps us learn about the shape or distribution of a sample or a population. Let's start out with the stem and leaf graph in example 1. We'll see that the following data in example 1 shows the number of wins by the Chicago Bulls from the 1991 season through the 2018-19 season. We need to construct a stem and leaf plot for this data. In order to do this, we are going to separate our data into what we call a stem and a leaf. And in this case, if we look at our data here, we will notice that our smallest data point is 15, and our largest data point looks like it's 72. So what we're going to do here is we're going to break the stem into our tens digit to be able to take both our maximum number of 72 and our minimum number of 15. Now, once we do that, we are going to look at our data in order from smallest to largest. Notice the 15 is the smallest, and then after the 15, we'll go to 17. What we do for that is, in this case, the 15 and the 17 will be listed as the leaf in this way. The 1 and the 5 represents the 15, the 1 and the 7 represents the 17. We'll notice that our next number in order is 21, and after the 21 we have a 22 here, a 23, and a 27. So once again we're going to go down to our row that begins with 2, and in order to enter the 21, we'll enter the 1, to enter the 22, the 2, 23. These are the final significant digits. We'll keep doing this. We'll notice that in our data there's a 30 and a 33. Now let's take a look at our data points in the 40s. There are 4 41s. So what we're going to do is write the 1 4 times. Then there's a 42, a 45, a 47, two 47s actually, a 48, and a 49. We're going to keep doing this in order from smallest to largest for each data point. We'll continue writing the final significant digit under the column for leaf. And that's it. We have our stem and leaf plot. And what's nice about the stem and leaf plot is it's a quick way to look for an overall pattern in the data. So here we can see that the most common data points fell somewhere in the 40s. In our box below, we're going to talk about outliers, and an outlier is an observation of data that does not fit the rest of the data. So for instance, let's say we had a data point like maybe 130. That data point would be really far from these points that we have in here for the number of wins. And at the bottom of our note sheet it says, do there seem to be any outliers in example 1? Perhaps 15 and 72 are definitely the low and the high, But they're not really an outlier because notice the 17 is still pretty close to the 15. The 69 is close to the 72. And we'll discuss outliers in more detail shortly. Let's go on to the next type of graph, and that will be our line graph on the next page. In example 2, we have data that shows when several people were asked how many years it has been since they purchased a mattress. And it looks like 2 people recently bought their mattresses. 8 people bought their mattresses a year ago. 13 people bought the mattresses 2 years ago, and so on. When we're drawing a line graph, you are going to want to have our vertical and our horizontal axis. We need to remember we must label our axis. So for our x-axis, we'll have this be the year since mattress purchased. And for our y-axis, we'll go ahead and let that be labeled the frequency. And from here, make sure to label the axes with the proper numerical values. The years that we're looking at go between 0 and 5. So we would want to make sure our x-axis consists of the numbers 0 through 5. It'd be silly for us to maybe make it go up to 20 in this case. But each graph can be different, so sometimes there's a little flexibility on how we label our axis and our increments. Since this is the frequency, we'll notice that our frequency goes from 2 to 22. So we'll want to make sure that our y-axis contains all the numbers from 2 to 22. Now you might have decided instead of jumping by 5s for the frequencies, maybe you would jump by 2s or perhaps 10s. There's no given rule, but just make sure that the numbers you choose fit your data. Let's go ahead and plot these points. So 0 occurred twice, so maybe about here. People who bought the mattresses within the past year, that occurred 8 times. Within the last 2 years, that occurred 13 times. So somewhere between the 10 and the 15 here. For 3, goes all the way up to 22. And then for 5, for 4, he went to 16. And for 5, he went down, the graph goes down to 9. And from here, we connect each pair of dots with a line, like so. And that would be an example of our line graph. In example 3, we'll be discussing our bar graph. And that talks about 6 high schools in a county, and each participating in a county-wide science competition. Our table here represents a breakdown of the competitors from each school and the percentage of the entire student population of the county. And from here, we're asked to construct a bar graph. So once again, we're going to start out with our vertical and our horizontal axis, and let's make sure we properly label our axis. And for our vertical axis, we'll let that represent the percentage or the proportion. Now we're going to break this up into the 6 counties. So we have Alabaster. Since all these start with a different letter, I'll just use the A for Alabaster, our C for Concordia, our G for Genoa, M for Mocksville, and I'll keep going with that. And for our proportion, you'll notice that our percentages seem to go between 8% as the lowest and 28.8 as the highest. So I might make my vertical axis reach to 30%. And let's say I'll jump by 5% here again. That's up to you. And these are the percentages. Now for our bar graph, we are going to make bars, rectangular figures. So for County Alabaster, it looked like 28.9% of those students were in the competition. So we'll make that bar reach up until about 28.9%. For Concordia, reached about 7.6%. For Genoa, we'll go to 12%. So the top of our bar will reach approximately 12.6%. Notice that the bars are not touching here. For Mocksville, 18.5%. So a little bit below the 20%. For Tennyson, 24%. And if you're working with a program, say like Excel, these bar graphs will come out really neat. And for West End, we have 28.8. So that's really close to our bar that represented Alabaster County. And there you have it. We have our bar graph. That is the end of the first video for section 2.1.